the square root basics. This is problem number 6 from the diagnostic. 4 radical 14 times 3 radical 21. So I have numbers on the outside of this, outside of square roots. We have 4 times 3, which is 12. And we could multiply 14 and 21 together and get some large number. But instead, I see that 14 and 21 have a common factor of 7. So I'm going to rewrite 14 as 2 times 7 and 21 as 7 times 3. I did that so I could get the 7s in the middle. All right, square root of 7 times the square root of 7 is 7. So on the outside, I have 12 times 7. On the inside, I have 2 times 3, which is 6. 12 times 7 is 84. So I get an answer that's 84 on the outside, square root of 6 on the inside. So this kind of problem is very similar to the last type of problem, but it had a little more complication because it had numbers on the outside. So if you want to try one like this, I will make up a problem for you. How about this times, and there's more than one way of doing these things, so don't feel bad if you do yours a different way, as long as you end up with the same thing that I end up with, all right? So how about this? So pause for a second and get the answer to that. I hope you're trying these on your own, because I think it really helps if you do them on your own before I go over them. So you should notice that 20 and 70, certainly 20 can break down to 4 and 5 because there's a 4 in there, but we'll get everything we need, I think, if we get there's a 10 that's in common between these two. Let's try that first. I could do the other way again in a second way. So 5 times 6 is 30. And I'm going to rewrite 20 as 2 times 10. I'm going to rewrite 70 as 10 times 7, so that I have the square root of 10 times the square root of 10, which is 10, times the 30 that's already on the outside. So I have 300 on the outside, 14 on the inside. And that works out kind of nice. There are other ways I could show of doing that, but if you got that answer, then you're golden. That's what you need to know. The next type of problem is when you have a fraction. The second part of rationalizing is that you can't have a square root in the denominator. And you might say, well, I don't have a square root in the denominator, but this is equal to the square root of 2 over the square root of 9. So there is a square root in the denominator. This one happens to be pretty simple and straightforward because the square root of 9 is 3, so there's really not a square root in the denominator. But if you have the next type of problem, square root of 3 over the square root of 7, it does have a square root in the denominator. The technique used for getting rid of the square root in the denominator is to multiply by a variety of 1, a version of 1, and that would be to multiply by the square root of 7 over the square root of 7, because that's another name for 1. And the reason why we do that is because square root of 7 times the square root of 7 is 7. Or you could say the square root of 7 times the square root of 7 is 49. Oh, and the square root of 49 is 7, but I think it'd be easier just to say it's 7. Square root of 7 times the square root of 3 on the top, they're both underneath the radical, so it's the square root of 21. Now, that doesn't simplify. It might look like it does, but it doesn't, because the square root of 21 has a square root over the top of it, and the square root of 7 does not. So a problem like that might be something like this. The square root of 5 over the square root of, 11. Let's try that. Go ahead and take a second, figure that one out. Rationalize by multiplying top and bottom by the number that's going to get rid of the denominator. So hopefully you paused and you get that you multiply by the square root of 11 over the square root of 11, because that's the magic number that's going to get rid of the denominator having a radical. Square root of 11 times square root of 11 is 11. The numerator is the square root of 55. And that's the way that works. The next one on the sheet is the diagnostic was real similar. It was like this. I don't think there's any difference to this problem here in the last 3 we've done. We multiply top and bottom by the 7, square root of 7. We get 7 in the denominator, and the only difference is that those don't multiply together like the last one. The last one, 5 and 11 multiplied because they were both underneath the radical, and this one doesn't do that. So the last one I have on this, the diagnostic, was a similar variant to the same problem, and it was 3 square root of 2 over 4 square root of 10. I would always recommend that you reduce fractions before you start. So 3 over 4 doesn't reduce at all. because they have no common factors, but 2 and 10, they're both inside the radicals. So you can say, oh, 2 over 10 is the same as 1 over 5. So I'm going to say this is 3 square root of 1 over 4 square root of 5. Now, I really didn't need to write square root of 1 because the square root of 1 is 1. 1 times 1 is 1. But I did anyway. So that's the way it is. Now I'm going to rationalize by multiplying by radical 5 over radical 5. And it gives me an answer of 3 square root of 5 on the top and 4 times 5 on the bottom, right? Square root of 5 times square root of 5. So that would be the same as 3 square root of 5 over 20. That's our final answer for that. Now, let's try one like that, where you have to reduce first. And I would always suggest reducing first because it'll make your numbers smaller. All right? So how about 6 square root of 6 over, how about 8 square root of something. All right, how about that one? So pause for a second and try that problem. So if you didn't reduce first, you need to go back and try that because it'll make it a lot easier. 6 and 8 have a common factor in them of 2, so I could reduce this to 3/4. 6 and 15 both have a common factor of 3, so we can divide 3 into 6 twice and 3 into 15 5 times. Oh, so it's almost the same problem as the one above it, but reducing first makes it easier to see that. Multiply the top and bottom by 5, square root of 5, and then we get 3 square root of 10 on the numerator and 20 in the denominator again because I reduced it first. Now, I know that's all that the ones that were on the sheet. I would recommend that you also look at the square root basics to see what's happening with that. That sheet has a problem that has something like, I don't remember exactly what it was, but if it was 5 square root of 3, well, let's see, 5 square root of, how about 5 square root of 7, I'll rewrite it, 5 square root of 7 over 3 square root of 12. Now, you can't do any reducing numerator to denominator to start with, but if you break down this 12, I guarantee it'll make it easier to do the problem. And remember that this is 4 times 3, so that would be 6 square root of 3, and that makes it a lot easier. If you multiply top and bottom by the square root of 12 over the square root of 12, then you're going to have big numbers to deal with. But with this one, notice that I have smaller numbers that I can work with, and I have 5 square root of 21 on the numerator. Since this is the same as 3, that's 5. 6 times 3 is 18 in the denominator. So I hope that this cleared up some of the confusion that was going on in class, or if it's something you haven't seen very much of, so that it'll be easier to do the work on this.